Hello everyone. The exact area under a curve is determined by applying the concept of definite integral, or the fundamental theorem of calculus. Examine the function f(x) on this x and y axis. So I'm going to draw this curve for you. So I'm going to identify this curve as the function f(x). I also want to identify this point as A and this point as B for x. Okay, so on the x-axis, I am going to identify point A and point B. Between these 2 points, I would like to calculate the area under this curve. So I would like to calculate this area here. In order for me to calculate the area between these 2 points, A and B, I must apply the fundamental theorem of calculus. So how do I do this? Okay, so basically, fundamental theorem of calculus indicates that given this function f(x) is continuous between these 2 points, A and B, it is very important to indicate that the function has to be continuous. So given the function is continuous, then you can integrate the function. If it is discontinuous, then you may not be able to apply this fundamental theorem of calculus. So the fact that this function is continuous between these 2 points, I am going to integrate. Okay, so I will apply the integral for this function. And then after that, I will calculate the difference between the 2 integral values. So after I evaluate this, I will have f. And in this case, I will substitute the value of b into x, and I subtract the integral that I found and evaluate that at the value of x equal to a. So basically is the value of the upper limit subtract the value at the lower limit. So the greater value is always the upper limit. The smaller value is always the lower limit. Okay, so in this case, we always identify the lower limit as a and the upper limit as b. So definite integral will have the value of upper and lower limits, and it varies. It can be negative, positive, and it also can be zero as well on this all the values on this axis. Okay, so there's no more constancy in this case because you have the exact area to work with. You have the upper and the lower limit to work with. Therefore, I would like to show everyone the fundamental theorem of calculus is summarized in these formulas right here. So I have the integral evaluate from the lower limit of a to the upper limit of p excuse me, at b of the function f(x) dx, then I can calculate the difference between the 2 integral values, right? So the integral values of b subtract the integral values of a. We make sure that we evaluate at the upper limit, subtract the value that we evaluate at the lower limit. Alright, so let's get started with an example. And I want to start with a very simple example here, where I will have the function and it's continuous at the point y equal to 2. So this function is y equal to 2, or f(x) equal to 2. Alright, so f(x) is equal to 2. Okay, so given f(x) equal to 2, it is a straight line, and I would like to identify the point 1 and the point 4 here, because I need to determine the area under the line y equal to 2 and between the lines x equal 4 and x equal to 1. So this is the line that x equal to 1. Okay, and this is the line that x equal to 4. So I identify this area. So this is the area that I have to find. So you probably tell me that, oh, it is just a rectangle. Then it's very simple. All you have to do is just evaluate this length which is 4 minus 1, so you should have it equal to 3. And this one should be 2 minus 0, so you should have this equal to 2. Okay, so the area is just simple as take 3 times 2, which is equal to 6. Okay, however, not all the areas that we are going to evaluate is as simple as this straight line. And not every function that we are going to deal with is a straight line. So if we have a curve like this, right? So we cannot apply just a simple formulas. We have to apply the integration. So I kind of want to convince everyone that fundamental theorem of calculus is actually very important and is applicable in real life. You applied it almost every day in engineering, especially mechanical engineering, when you have to calculate the area and then you generate that area into certain shape. Okay, so I start off with this simple function so that I can convince everyone that fundamental theorem of calculus works every time. So let's take a few minutes to go over the complicated method, and then we can, at the same time, we can prove this fundamental theorem of calculus works as well. All right? Okay. So I'm going to write the integral from a to b, right? So here is the formulas that I need to remember for myself. Okay, so it's summarized in that formulas. So I will write it as the integral from a to b, which is from 1 to 4, right? Okay, so you write the lower limit down here and the upper limit down here. And for your function fx, what do you write? You write 2, because fx is equal to 2. And do not miss the dx. So then what you have as a result is the integral evaluate at 4, subtract the capital F, integrate or evaluate at the values x equal to 1. So let's start with that. So what I have is this should be equal to integral from 1 to 4, and I'm going to write 2 times x to the exponent 0 here. Okay, because I need to have the variable raised to an exponent, and then I add 1 to that exponent divided by the result. So you can bring 2 across the integral sign and x0 dx. So I add 1 to the exponent divided by the result. The integral should be equal to x. So now I have 2 times x. So how do I present my upper and lower limit in this case? So the required notation is you have to have a straight line, and then down here you are going to write 1, and up here you are going to write 4. So in the way that you are telling the readers, so this is mathematical language, we need to learn how to get familiar ourselves with this language here. So after this line, it means that I'm going to apply this theorem. Okay, so I am going to put f4 subtract f of 1. So it means my f, capital F, now is equal to 2x. So where the values of x, I will substitute the exact value given for me as x. So I will take 2 times 4, and I subtract the capital F of 1, which is capital F now is just also 2x, but I will substitute for the value where x equal to 1, so 2 times 1. So now apply back math, so you multiply first and then we subtract. So this is 8, subtract 2, I also have 6 as the final answer. You see, so in this graph or in this figure, we just have a rectangle, and it's as simple as 3 times 2, we have 6. But if we apply fundamental theorem of calculus, we also have 6 as well. So now we are going to move on to another shape, and this shape definitely I cannot apply like any simple formulas that I learned in elementary school, because I need to calculate certain area, and it's not like a rectangle or a square or a rhombus or or any other easy shape or the circle that I have learned in the past. Okay, so let's take a look at what they want me to do here. So determine the area under the curve y equal to x squared plus 1 and between the y-axis and the line x equal to 4. So they are giving you the two limits here, the between the y-axis. So the y-axis right here, then x is equal to 0. Okay, everyone recall that the equation for the y-axis is actually x equal to 0. Okay, and the line x equal to 4. So x equal to 4 is right there. And this parabola that they are giving me is identified as y equal to x squared plus 1, which is absolutely true because I can see the vertex is right here. So 0 and 1. So they would like me to evaluate this area. Okay, determine the area under the curve and then between these two points, upper and lower limit. So I can go ahead and apply the fundamental theorem of calculus. So to do that, at first you may want to write down the formulas. Okay, so I'm going to write down the formula as integral from a to b. Next example, I will not repeat this. Okay, f of a. Okay, so to calculate this area, I will need to do it like this. I need to write it like this. The area will be equal to the integral, and what is your lower limit? Is a smaller value, which is 0. Your upper limit is the bigger value, which is the 4, so 0 and 4 for x. And what is your function in this case? Your function is this one, right? So we have x squared plus 1. Don't forget we multiply by dx. And what is that equal to? Okay, it will be equal to the f, capital F of 4, subtract the capital F of 0. Alright, okay, very good. So our next step is to integrate the function x squared plus 1. And I believe that everyone already remember how to integrate this simple integrand. So a equal to 0 to 4 x squared plus 1 dx. Okay, so what is the integral of x squared? Is 1/3 x to the exponent 3. What is the integral of 1? Is x. Alright, yeah. Then what I do is I will write that straight line from 0 to 4. And what do I have to write next? The f of 4. So subtract the f of 0. Okay, you see I skip a few steps in between here because at this point I can tell everyone that you can break this into two individual integrals of integral of x squared and then integral of 1, also evaluate at the same value 0 to 4, but we do it in one step here. The integral of x squared is 1/3 of x cubed plus 1. That means plus x as the integral of 1. Okay, so let's evaluate this. Okay, so I will do step by step for everyone. So I will, first of all, the f of 4, right? So f, capital F of 4, it means 1/3. And I substitute the x as 4, this is to exponent 3, and plus x, which is plus 4. So this is my first integral. Evaluates at these values. So this is my f4 in this case. Now I will subtract, okay, 1/3, 0 to the exponent 3 plus 0. Okay, I know that everyone realize this one is actually equal to 0. However, I want to demonstrate for everyone that we subtract the lower limit in this case. Even though it's 0, we should indicate that because most of the time, sometimes this is not actually equal to 0 all the time. So it's a good idea that we have to write that down. So when we evaluate this, what do we get? We get 64 over 3 plus 4. Subtract the 0, so I should have 64 over 3 plus 12 over 3. As common denominators, I should have 76 over 3 as my final answer for the area under this curve. And this curve is continuous between the point 0 and 4. So this green area that I indicate to you, it should be equal to 73 over 6 unit square. All right? Okay. So, okay. So far so good. So we can continue to example number 3. I just want to make a note for everyone that I give myself a lot of space here. So I'm going to show everyone to go all the way to this page so that we can start with example number 3. And I still have plenty of time. Alright, so I'm going to determine the area under the curve y equal to 4 minus x squared that lies in the first quadrant. Okay, in the first quadrant only. So let's examine our x and y axis. So here's my x. Here's the y axis. Okay, and here's the x axis. Alright, okay, so I have to work with this area only because it's only in the first quadrant. So you may want to identify the area first. Okay, so this is the area that you have to look for. Okay. So to find this area, you are going to identify your upper and your lower limit. Okay, so your upper limit in this case will be equal to 2, and your lower limit in this case is equal to 0. Because they only want us to determine the area that lies in the first quadrant. Okay, so it is very simple to find the values of the upper and the lower limits. So we have done that already. So we are going to write area A will be equal to the integral. Okay, so what is your lower limit? 0. Your upper limit is 2. What is the function that you are working with? 4 minus x squared. Don't forget to write the dx in this case. So what it will be equal to will be your f of 2, then subtract the f of 0. Okay, so let's work with this. Excuse me. So area from 0 to 2, 4 minus x squared dx. Okay, can you remember that I will skip a few steps here. I will just integrate straight from this integrand. Okay, I'm not going to break this into two individual integrals to integrate. So I will just say that integral of 4 is 4x. Alright, okay. The integral of negative x squared is minus 1/3 x cubed. Okay, so then I need to write from 0 to 2. And now, so what is my f of 2? My f of 2 will be 4 times 2, subtract 1/3, 2 raised to exponent 3, and put this in this bracket, and identify this is my f of 2. And the second part, f of 0, is actually equal to 0. However, it's a good idea to write that down as well, because we may not have it equal to 0 all the time. So this also 0 to the exponent 3. And close that. So this is my f of 0. Then, what do I have at the answer? This is 8 minus 8 over 3. And that should be equal to 0. So I should have 24 over 3 subtract 8 over 3. So my answer should be 16 over 3 unit square. Alright, so the area that they asked me to find right here will be equal to 16 over 3 unit square. Okay, so let's see if I have any more example to work with. I don't think so. But I do have some exercise for everyone to work on in this case. So please try this question. And then what you do is you can check the solution online. In my next lesson to you, we will explore further into the fundamental theorem, and we will determine very complicated area, and you also have to use your algebra to figure out the upper and the lower limit. Alright, thank you everyone.